is the Morpho butterfly. It's probably a butterfly that's about this big. It's this beautiful, beautiful iridescent color, has kind of metallic looking. And again, this is not through pigments. It's not the chemical basis for it. It is just the way these things are arranged on its wings. And we'll just call them these little Christmas trees. So each little piece of the wing is formed of scales, say, overlaying hands. And on these hands, you have these Christmas trees. And on this top one, you see this high occupancy rate really closely together, these Christmas trees, and that will give this iridescent color. And that is for this Morpho butterfly. But a different species, still pretty iridescent, pretty metallic looking, but less so. It's because it has more diffraction. It's because it has these different layers, discrete multi-layers on the scales with overlapping Christmas trees, and that causes more diffraction, which causes them to be less iridescent. So just by playing with these structures, you can create different colors. The emerald swallowtail is one of the only butterflies that has actually a green color. Nowhere here in Illinois is there a green butterfly. And this green color is also achieved due to structural color. Here are these scales, these overlapping hands that I used as an example. These scales, and they have these concavities on the scale. And if light is shown onto it, you can it will bounce back in different ways. If the light hits straight on, it will bounce back as a yellowish color. If it hits just slightly off, like onto the sides here, it will bounce off as a blue color, and together it will make this beautiful green color. So no pigments involved, just these photons. Okay, another one are these beetles. They're this Brazilian beetle, also called diamond rough for obvious reasons. Very shimmers a lot. It has a unique green color, and it has that because it contains these photonic crystals on its wings, on its body, on the body itself, not even on the legs. And individual scales on the beetle then reflect this iridescent green light due to these microscopic diamond-like structures. Again, there's no pigment in here. It's just the way the light hits these microscopic structures and how it bounces back in and how do we perceive it. The next one is the inspiration are these white, this color white on this beetle. This beetle lives among fungi that are also white, so it likes to be conspicuous, so it wants to be white. And this whiteness requires, of course, the scattering processes. That's how we get light. There are a lot of the appropriate visible wavelengths are scattered. And this is just is a result of the 3D photonic solids on the scale. Again, there's something about the scales and how the structure of the scales are that they can be this white. And these scales are only 5 microns thick. And this white is actually far whiter than we can make, for instance, our Xerox paper. And also 5 microns, we can never get it that thin. And it's basically, here you see all these little scales that are on the back of a beetle. And just here's a cross section, like if you cut the scale, you see it's very rough, but there must be some reason for this, because that is how the light is then scattered back and we perceive it as white. So this is actually not a random, you see cross-section, not a random organization of the structure. It is, there's a reason for this, and it will result in a white color. So people have tried to apply this, and they may, one of the ways you can do is actually use the actual wing as a photonic material. It's like the whole wing by dissecting the forewing of this butterfly and then soak it, and get rid of all the underlying, most of the outer structure, soak it, and then dip it in zinc oxide, and then you get an exact replica of the wing with all its structures. And then if you shine a light on it, you may get a similar color as here. Just here, which is, so your replica is actually sort of a stamp of the actual wing. And that is with variable success. Here you can see this is the replica, which has some color. Again, not due to pigment, but because of the structure of the wings. And I think on the left-hand side is the actual wing, and here is the replica. So the stamp from the wing. So they're pretty successful. And here's another example of where they get this from another type of butterfly. They also did get they used a faded wing, then mineralized it with CrO2, and then if you then shine light on it and look at it from different angles, you do get this iridescent color showing up. Okay, so the application for this is that structural coloration can be used for design and fabrication of novel materials, and most importantly, photonic materials. Photonics seems to be like the next step after electronics. They may be building blocks for nanoscale devices, such as UV light emitting cones. And like I said, photonics is dependent on these photonic materials, as seen in butterfly wings, so we can increase bandwidth